everyone. Today we want to take a look at trigonometry again, and then we're going to be focusing ourselves on the trigonometric ratios, which is the trig ratios, and then we're going to use the trig ratios to solve triangles or any figure that is in the shape of a right angle triangle, right? So let's get started. First thing that we need to know in terms of trig ratios is the three trig ratios that we have. We have sine, we have tangent, and then we have cosine. Those are three trig ratios that we will be working with. In terms of the ratios or the formulas, it is going to be sine. Sine is written as sin, and then the sine of theta equals to the opposite over hypotenuse. The cosine of theta equals to adjacent over hypotenuse. And then the last one, which is tangent of theta, equals to opposite over adjacent. And then those are the three formulas that we're going to be using. Notice that you could either use sine, cosine, or tangent. Now, depending on how the triangle looks, we will be using one of those. What kind of triangle can we use, or we can apply those trig ratios? The triangle has to be a right angle triangle, right? So that is the only time when we're able to use trigonometric ratios. So if it is not a right angle triangle, we're not able to use this trig ratio. That's one of them. So let's quickly take a look at what we have in terms of the triangle. The triangle is going to be like this one. Now notice that the triangle has a little box in one of the corners. What that little box means, it just means that in that corner the triangle forms the 90 degrees, right? So we have 90 degrees here, right? Let's call this triangle A, B, C. Alright, what can we solve by using trigonometry or the trig ratios? We can solve for a side and angles. We can solve for a side and angles by using this trigonometric ratio, which is sine, cosine, or tangent. There is a easy way to remember the trig ratios. I think you have heard of this one, the Sohcahtoa. Right? I think you guys have heard of Sohcahtoa. What it actually means is just the same thing that you have up here at the top. So SOH is sine of theta equals to the opposite, which is the O, and then over hypotenuse, which is the H. Ka, which is cosine of theta, equals the adjacent at the top and the hypotenuse at the bottom. And then the last one would be tangent of theta equals opposite at the top and then the adjacent at the bottom, right? So that's an easy way of remembering the trigonometric ratios. Let's take a look at an example. Oh, by the way, before we continue, you will need a calculator, right? You need one of those calculators, scientific calculator. Now notice that when you have a calculator, your calculator, to work with trigonometry, your calculator must be in degrees. Now some of you guys might have it like my one, it's in radians. We cannot work with radians whenever we're solving trigonometric problems or triangles. So what we need to do is we need to change that to degrees, and then with this calculator, notice that what I do is just press here and then it changes to grad, and then if I press again it changes to degrees, right? So first thing that you need to do is to make sure that your calculator is in degrees. If you don't know how to do that, then I guess you need to read the little manual. Sometimes at the back you will notice that there is a reset button. You will see that there is a small little hole at the back, and then what you do is with your pen you just press it in, and then you will notice that everything goes back to degrees, right? So make sure that your calculator is in degrees before you're working with trig ratios, right? After you've made sure that it is in degrees, then you can start working, right? So let's take a look at what we have now. In terms of trigonometry, you can solve for a side. So let's start off solving for a side. Whenever you're solving for a side, what you need from the triangle is that the triangle will be a right angle triangle. A side and an angle must be given, right? A side and an angle must be given. So whenever you're solving for a side and an angle must be given, right? A side and an angle must be given. Of course it has to be a 90 degrees triangle. So let's take a look at an example. Let's say that you decide to lean a 25-foot ladder against your house, right? So let's say you measured your ladder is 25 feet, and you decide to lean that against your wall. We have the ground here, right? We have the ground there, and then we have your wall going up this way, right? Let's say that you have that. Let me see if I could draw a little wall here, right? So it's a concrete wall, and then we have something like that. So that's your wall, that's your ladder, and then let's say that you find out that the angle it forms here, the ground and the ladder forms an angle of 35 degrees. What would be the height of the wall where the ladder hits the wall or touches the wall, right? So whenever you're solving trigonometry, the first thing you have to see is, one, it is 90 degrees. Where does it form the 90 degrees? It forms the 90 degrees right here where you have the wall and where you have the ground. So this is where you have the 90 degrees, right? So you have 90 degrees there. We're trying to find what is the height of the wall, which is this here. So let me put X there, right? So if I take a 25-foot ladder and I set it against the wall, the angle it forms is going to be 35 degrees. How high up the wall would the ladder reach? Alright, so first thing we need to do is label your triangle. How we're going to label it. Now notice that your formula needs an opposite, needs a hypotenuse, needs an adjacent, and then hypotenuse is repeated again here, opposite and adjacent, right? So you need an opposite, an adjacent, and a hypotenuse. When you take a look at the triangle, what we do is we identify where the angle is given. If you notice, the angle is given right here, which is 35. So I will say that my opposite is going to be opposite to the angle given, 35. so my opposite is here, right? So whenever you have the triangle 90 degrees, where is the angle given? The angle given is right here, which is 35. So opposite to it is the opposite. The hypotenuse is always opposite to the 90 degrees. So always try to identify where the 90 degrees is, and then opposite to it we have it is the hypotenuse. So let's label it as hype. And then the bottom one, we have that it is going to be, of course, the last one that we have and we haven't mentioned, which is the adjacent, right? So that is how you're going to label. Take a look at the triangle, identify where the angle is given, or if let's say you're solving for this angle, then you guide yourself from that angle, right? So you start labeling from the angle given, or if you're solving for that angle, then you start labeling from here. So that's going to be opposite. Find where the 90 degrees is. Opposite to the 90 degrees is going to be your hypotenuse, and then the last one is going to be your adjacent, right? There are other ways that I've heard students make mention of finding the opposite, the adjacent, and the hypotenuse, but in my case I always try to explain it this way. Take a look at where the angle that is given, or the angle you're going to use to solve the problem, and then from there you label, right? Reason is because then we could find what is this angle, right? We could find this is 90, this is 35. We could say it is 100 minus 35 and the 90, and then we get this angle. If we find this angle, then we could quickly say, or we could change it and say I'm going to use this angle here, and then I will use this angle to solve for the height of the wall, and then this would then change to opposite, right? Because we will be using the angle which is over this side, right? I'm just saying. But let's take a look at another one, and then we go back to this one, right? So don't forget that one. So let's see if you have a triangle. In this case, let me just quickly draw a triangle. Let's say that the triangle is right there, this way. The 90 degrees is going to be set on that side. Let's say that this side is given to be 14 miles, right? And then we have that this angle here that is given to us is going to be, let's say, 42 degrees, right? So we're solving for a side, and then what must be given? A side and an angle must be given, right? So we're solving for a side, and then we're given an angle and a side. Let's quickly just indicate which side we're going to be solving. We're going to be solving for that side, right? So to start off, it is a 90 degrees. We are going to now label. We identify where the angle is given. This is this 42 there. Opposite to it, we have it is the opposite. Then we identify where the 90 degrees is here, and then opposite to it is going to be your height, right? So that is what we have. And then of course the last one is going to be your adjacent. Once you have done that, then you can start working. Start off by labeling. If you don't understand how to label, go back to the video, and then you will notice, or you will find out how to label. Always identify the angle that's given. Opposite to it is your opposite. Identify where your 90 degrees is, and then opposite to the 90 degrees is your hypotenuse, and then the last side that is left is going to be your adjacent. Once you have done that, then you need to take a look at the formula. The formula is this here: sine of theta equals to opposite over hypotenuse, cosine of theta equals to adjacent over hypotenuse, and then tangent equals to opposite over adjacent, right? I don't want to write this entire thing again, so I will use the short way, which is Sohcahtoa, and then this is what I'm going to say. Sohcahtoa. I'm going to say Sohcahtoa. Once I write that down, I will first start off by identifying which side I am solving. Right? So I am solving for which side? If you notice, I am solving this side here. This is the side that I am solving, represented by x, which is the height of the wall, and we labeled it as opposite, which means that within our formula, within those formulas right there, I must have the opposite included. Does sine have the opposite? Yes. So it could be that I'm going to use, that formula that I'm going to use. Does cosine have the opposite? No. We have adjacent and we have hypotenuse, right? So this is out. Does tangent have opposite? That's going to be yes. So it's going to be between sine and tangent. So let's continue. So opposite must be in there. This is the one that I'm solving. Let me just put a question mark. In order for us to use tangent or sine, we must have the other information, right? The other information, I'll do it this one time, but for the second one I won't do it again. You have theta opposite over hypotenuse, and you have tangent theta, that's opposite over adjacent. That's the formula, right? So if I take a look at sine of theta, theta here represents the angle, right? So this here represents angle, and then I have the angle, which is going to be 35. So that means I have theta and I have theta, which is the angle that's going to be 35. Opposite is the one that I am solving, so that must stay there. So I have opposite there. Is the hypotenuse given for this one? If you take a look, do you have a number for the hypotenuse? That's yes. So that means we're going to use sine. If you take a look at tangent, do we have a length or do we have a number for the adjacent? And that is going to be no, we don't have that one. So in this case, we can't use that one. Why? Because whenever you use any formula, there can only be one missing, right? So this is what we're going to be using. It's going to be sine, right? Once we have that, then we just immediately say, all right, it's going to be sine of theta equals to opposite over hypotenuse. Opposite over hypotenuse. Then you insert the numbers that you have from your triangle. You have theta, which is going to be the angle or the angle you use to label the triangle, and then you have the hypotenuse here. So immediately after that, you will say sine theta is going to be 35. So sine of 35, right? Sine of 35 equals, what is the opposite? The opposite is what we need to solve. So you leave x there, okay, just indicating that that is what we're solving. And then the hypotenuse is going to be 25. So we have sine equals to 35. Sine of 35 equals to x times 25. The next thing that we need to do is we need to get rid of that 25, leave x by itself. So we're going to say, all right, so we want to get rid of this 25 such that x is by itself. So how we get rid of a number that is in the denominator? We're going to multiply it by 25, right? And then what we do to this side, we must do it to this side, right? So you multiply 25 on each side. This 25 and this 25 will cancel off. Now notice that what we're going to be having is going to have 25 times sine of 35 equals to x. That's what we have. Once you get that there, then the next thing that you need to do is use your calculator to get your answer. Use your calculator to get the answer. That is going to be 25. Now in this case, if you have the calculator, also if you have the calculator that displays your number, you could just quickly go and say 25. Right? If you have the calculator that displays, means that whatsoever you put in there and you say plus and then you continue, it does not erase it and then it just leaves it at the top. That displays the information that you're entering. You could do that 25 times sine of 35 and then get your answer. But notice if I do that 25 times sine of 35, I get 875. That is completely wrong, right? So with those calculators like my one, then you have to do it a little bit different. You will have to say 35 sine, you have to go like in backwards kind of way. So you enter 35 sine, that gives you that long decimal there, and then times, and then we have it is 25, right? And then if we do that, you notice that what we get is 14.3394191 equals to x. Right? Now, you see why I had to do approximation first, because whenever you do that, or whenever we're working with trigonometry, you're going to get a lot of answers that's going to be in a lengthy form like this, long amount of decimals. So what we're going to be doing here is we're just going to say, alright, I will approximate to 2 decimal places, and that's going to be 14. So approximately, I forgot that part there, approximately those two little curly things there, and then you put this 14.3, and then that changes to 4, because remember this is what we're approximating. The number that follows is a 9, so I must add 1, so that's going to be 14.34, and then don't forget your units. That's going to be the other one. Let's quickly do the other one. The other one we have already labeled. This is the triangle that we have. We're solving for this side. We are given 14, and that's the opposite, and then the theta, which is going to be 42, or the angle we're using to solve it. The formula is going to be Sohcahtoa. So let's quickly just add in that Sohcahtoa. I must use the formula where the adjacent is found, because I am solving for this. So do I have the adjacent here? No, so I immediately eliminate sine, right? So it's between cosine and tangent, right? So cosine has the adjacent here at the top, so that's what I'm solving, and then the tangent has it at the bottom, and then that is what I'm solving. Which means the next step that I need to do is just identify or make sure that the other two informations are given, right? What are the other information? Let's quickly take a look at cosine. Is theta given? Theta is 42, so that means it's given there. Is the hypotenuse given? Take a look at the hypotenuse. It has no number given to us, so that means we cannot use this, right? The one that we're solving is the only one that can be missing. Adjacent is missing. Is the opposite given? Yes, that's 14, so it's given there. Is theta given? Theta is 42, so that means I'm going to use tangent, right? As soon as I do that, then I just quickly say, alright, tangent of theta equals to opposite over adjacent, right? That's the formula there. Then I will go tangent of 42 equals to opposite, which is 14, over the adjacent, which is x, right? Opposite is 14, so I replace the 14 here, and then the adjacent is x, so I place the x up there. All right, now with this problem, how do I solve for x? Now I cannot see it, get rid of that x or get rid of the 14. Now how do I work this one? You will start off by saying times x. Okay. First eliminate the denominator, which is the x there, and I will say times x there, right? This x and this x goes off, or they cancel off, and then you have it, then you have x times tangent of 42 equals 14, right? That is what we have at this point. Tangent x equals to tangent of 42 equals to 14, because we got rid of the x here. Next thing that we need to do is we need to get rid of this tangent of 42. Because it's multiplication, we will say divide by tangent of 42, divide by tangent of 42, and then this goes off. X equals 2, and then you solve this using your calculator. Right, so let's go back and let's say, all right, so what we're going to have, it is going to be 14. And again, remember, if your calculator displays everything that you're entering, then you could say 14 divided by tangent of 42, and then you get your answer. That is going to be straightforward. But if you have a calculator like my one, you will have to say 14 divided by, right? So divided by, and what I'm going to do is I'm going to put tangent of 42 in brackets. Open bracket, 42, tangent right here, close bracket, and then equals. My answer, if you take a look at it, is going to be 15.547,521, right? So that's the answer that I get. Now, in some cases, your triangle will have something like this. What does that indicate? What does that tell you? It tells you that whenever you get your answer, you will get something like this with so many decimal, but you will need to just round off your answer to 3 significant figures. We already know how to solve 3 significant figures, so we're going to say, all right, x is approximately 3 significant figure. That's 1, 2, 3. That's this 5 here. Because it is a 4 that follows, it remains as 5, so that's going to be 15.5, and then again our units, miles. Right, so that is what we have. I will do another video with more examples when it comes to trig ratio and solving for a side. We still need to do the other one with the angle, but I will do another video showing you more examples with solving for the side. But at this can give you a better idea of what you need to do. Right, I hope you like it. Please like the video, and if you have any comments or any questions, please post it, and I will respond to you as soon as possible.